Condition of obtaining maximum current from a mixed combination of cells. For that we can draw a diagram. We can draw a diagram that is mixed combination of a number of cells. So these are the cells in a row. Then we can draw the second row of the cells. There are n number of cells in each row. First cell, second cell of the second row, then nth cell of the second row has been drawn. Then we can draw mth row. This is the first cell, second cell, then a number of cells. Finally, there will be nth cell in mth row. So this is the parallel combination, mixed combination of mn number of cells, and this mixed combination of cells will be connected to an external resistance. This is the external resistance. This is the external resistance. We can draw. This is the external resistance which is connected to the mixed combination of cells. So this is the diagram of mixed combination of cells. E is the EMF of each cell. R is the internal resistance of each cell, and we can denote the EMF and internal resistance of all the cells in this mixed combination of cells. Again, we can denote the EMF and internal resistance of the cells in mth row. R is the external resistance. Capital R is the external resistance. This is the first row, second row, and mth row of this mixed combination of cells. First cell, second cell, and nth cell of the first row. So there are n number of cells in each row, and there will be, and there are m number of rows in this mixed combination of cells. Let an external resistance R, capital R, be connected to a mixed combination of m dot n number of cells. Here n is the number of cells in each row, and m is the number of rows in this mixed combination of cells. M is the number of rows in this mixed combination of cells. V is a potential difference across the external resistance capital R, and I is the current, total current generated from this mixed combination of cells, and this current I will be flowing through the external resistance and return to this current will return to the mixed combination of cells, and current will be flowing in this way through the cells. That means current flows from negative terminal to positive terminal inside the cell, and outside the cell this current will be flowing from positive terminal to negative terminal. The current flowing through the external resistance, the current flowing through the external resistance R flowing through the external resistance R is given by I equal total EMF divided by total resistance. Total EMF in each row is NE, and that is also the total EMF of Mn number of cells. NE divided by R plus NR by M, where R is the external resistance and NR is the total equivalent internal resistance, where NE is the total EMF. Total EMF. NE is the total EMF of each row. That is also the total EMF of the mixed combination of cells. NE is the total EMF of each row containing n number of cells in series combination in each row. N number of cells of EMF E, and the total internal resistance and internal resistance R. Each cell has EMF E and internal resistance R, small r. Also, NR by M is the total EMF, total equivalent internal resistance of total equivalent internal resistance total equivalent internal resistance of Mn number of cells. Mn number of cells. Therefore, I equal Mne divided by Mr plus Nr. Equation 1. I equal Mne divided by Mr plus Nr. Equation 1. Or I equal Mne divided by root over Mr minus Nr whole square plus 4 MnRR, 4 Mn, Mn small m small n small r capital R. This is the another expression of the current flowing through the external resistance capital R, and this current is also generated from the mixed combination of cells. Equation 2. Now this current I flowing through the external resistance, R, capital R, external resistance capital R, will be maximum if the denominator of the current I becomes minimum, that is root over mr minus nr whole square. 4 mnrr is minimum. The denominator will be minimum if current I is maximum. So now this term root over mr minus nr whole square plus 4 mnrr will be minimum provided mr minus nr is 0, because mnrr cannot be 0. That's why mr minus nr will be 0. Here the current I will be maximum provided its denominator, that is root over mr minus nr whole square plus 4 mnrr is minimum. I will be maximum if this denominator is minimum. That's why root over mr minus nr plus 4 mnrr is minimum. So now 4 mnrr cannot be 0. Hence, difference of two quantities or numbers may be 0. That's why mr minus nr is 0 for obtaining maximum current. For having the denominator minimum, mr minus nr will be 0. Hence, mr minus nr equal to 0. Therefore, mr equal nr. Therefore, R means capital R. Therefore, capital R means external resistance equal nr by small m. nr by small m. So this will be the required value of external resistance which to be connected to the mixed combination of cells for obtaining maximum current from the mixed combination of the cells. Therefore, external resistance, R is the external resistance and nr by m is the total internal resistance. External resistance equal total internal resistance. Total internal resistance. Therefore, Imax will be what? The expression of maximum current flowing through the external resistance will be. So before that we can write what? Therefore, if the external resistance capital R is equal to the total internal resistance of internal resistance. Total internal resistance NR by M, internal resistance NR by M of the mixed combination of cells. Mixed combination of cells mixed combination of cells mixed combination of mn number of cells mn number of cells mn number of electric cells if the external resistance capital R is equal to the total internal resistance NR by M of the mixed combination of mn number of cells, then the current flowing through the external resistance current flowing through the external resistance flowing through the external resistance capital R, current flowing through the external resistance capital R will be maximum. Therefore, what will be the expression of maximum current flowing through the external resistance? Imax will be in MNE divided by MR plus NR. It was the actual expression equal MNE, not MNE. So we can write down the expression which is NE. NE, number of cells in each row is N. E means EMF of each cell divided by R plus NR by small m. Hence Imax will be NE NE divided by 2R. Since R equal NR by M, where R equal NR by M. So this is Imax. Therefore Imax equal to NE by 2R. NE by 2R. This is the maximum value of current flowing through the external resistance. Imax equal NE by 2R, which is the maximum current flowing through the external resistance which to be connected to the mixed combination of cells. External resistance are connected to the mixed combination of cells. Combination of cells.